Hello, ladies and gentlemen, Mr. Gasta here. Today we're going to do an introduction to chemistry, and that's always going to start with the periodic table. Here we have the periodic table of elements, and these are 118 elements that basically anything and everything in the universe are made of these. Okay, so these are the building blocks of every single thing in the universe. So there are some things you may be able to recognize, just the names of hydrogen here, carbon, nitrogen, oxygen, nickel, calcium. Um, so, right, Au is gold. So, um, this is similar to like having a box of Legos here. So I have a box of Legos, and they're all different. And here they're all loose, so they'll be individual elements because they're all loose. But as we start putting them together, snapping them together, they can make different shapes and structures. And that is similar to what happens to these elements. They get sort of snapped together. We call them bonding to form different to form everything that exists in the universe. So we're going to focus on just some of the more common elements that we see on Earth. So for our example here, what we're going to use is the hydrogen will be this red piece here, and the carbon over here is going to be this white. The oxygen will be this green right here. That's going to be oxygen. And then the Na is sodium. That will be the pink one. And then calcium was going to be this orange one. So using Legos, I'm going to try to just do a little introduction to how chemistry works and molecules work. So our first example will be water. What does the chemical structure of water look like? So we're going to do water, and probably maybe you know the chemical formula for water is H2O. H2O. That means two hydrogens bonded to one oxygen. So in this model, the oxygen will be the green Lego, and the hydrogen will be the red. And because it's H2O, we will need two hydrogens. Now, what I want to say is, so how this works is, and this is related to chemistry, is we have our two hydrogens and one oxygen, and they're bonded together. Okay, so these here, I'm snapping them in like this, and I'm snapping them together like this. And so what we have here, it would be what a hydrogen molecule will look like, or at least a model of one, right? So, and you know, they're snapped together on those brown pieces represent the bonds. Okay. This for our model. Our next model is going to be oxygen. And while oxygen is an element, will be the orange is calcium, white is carbon, and gas that you and I breathe. So the formula for oxygen gas is O2. So it is pretty straightforward in that it is just two oxygen that are bonded together. So it would be like this. Oxygen molecule. Our next model is sodium chloride. If you don't know what sodium chloride, it is something that we all know well, and it is table salt. So for instance, get some salt out of my salt shaker, right? Let me see if I can focus on that. So table salt. That, the chemical, the name in chemistry is sodium chloride. So that would be a sodium atom combined, bonded to a chlorine atom, and like this. So again, these are pretty simple examples I'm using. And there we go, sodium chloride, table salt. Our next model will be calcium carbonate, CaCO3. Now, you probably don't know what calcium carbonate is, but basically calcium carbonate is what makes up most shells you may find on the beach or growing in a lake. Shells are mainly calcium carbonate, so to give you some real world perspective. So This for our model will be the orange is calcium, white is carbon, and the green is the oxygen. So what we have here is these are our elements here. Okay, one calcium, one carbon, and three oxygens, and they're going to be bonded together. In this case, our bonds are going to be, we're using blue ones for this. There are different types of bonds in chemistry, and that really matters. But for our purposes, we're going to we're not really focused on the bond so much. So this is what the structure is going to look like. So we have the carbon sort of in the middle. Okay. Okay, we go this. So bond oxygen. So we bond oxygen there, oxygen there, oxygen there, and a bond here, and then there is a bond here, and then those bonds too. The calcium like that. So that represents calcium carbonate, which is what makes up most shells. Our next model is going to be isopropyl alcohol. If you don't know what that is, it is a common thing in that it looks like this. Get it at the drugstore. We often refer to this as rubbing alcohol. And this is what makes up most of hand sanitizer. So a lot of hand sanitizer in COVID times, for instance. This is what that is mostly. Okay, so the formula here is C3H8O, and so we need 3 carbons, 8 hydrogens, and 1 oxygen. Okay, so let me build this here. Okay, that is our model of isopropyl alcohol. Right, so what we have here is 3 carbons, 8 hydrogens, which are the red, and 1 oxygen. Propane is up next. Now, propane is C3H8. What is propane? This is my barbecue grill. And in that tank right there, that tank is filled with propane, which is the fuel for the cooking we do on that grill. Yum. Now what I'm going to do for propane is I'm going to take the model that I just made for isopropyl alcohol, okay, which, if you notice the formula here, it is very similar. Isopropyl alcohol has an oxygen and propane doesn't. So I'm going to just, this is an idea for how chemistry works oftentimes. So to make this the structure of propane, what I need to do is just remove this, okay? And now that is propane. They are very similar, but propane doesn't have the oxygen. And just the removal of that oxygen makes it very different, right? Propane and rubbing alcohol, isopropyl alcohol, are very different just because of that small change. And that is a common thing in chemistry. One small change can cause a compound to have very different properties. Okay, so that's our introduction to chemistry using Legos. And I'm Mr. G. I hope that you enjoyed learning about chemistry through Legos as much as I enjoyed getting my old Legos out and getting to use them again. So fun. Who does not like Legos? See you next time.